In the previous video, we mentioned that in the circuit of the source we have some additional components that are connected with these two cables. The additional component that is inside the circuit of the source, but we can say that it is not the same as the circuit of the source, but rather it is in the middle of the control zone. This is the PFC circuit. The PFC circuit is composed visually. You will be able to identify it quickly in inverter equipment because what you will see is a reactor. This component is not a transformer. What it does is let electrons pass through it and come out, nothing more. What is its function? What problems does it bring in inverter? Well, if this component is in bad condition, the problem is not that the source stops working, but that it will mark some kind of error, such as overcurrent error of the equipment itself. You will always find this component near the motor compressor. I will show you an image so you can see where it is. You will find it here, near the motor compressor. If you don't see it, it is very likely that it is on the electronic board. It can also be mounted on the electronic board. Here we have it near the motor compressor, here we have the fan, and here we have it mounted on the board. The question now is, where is it placed? What problems does it present? How is it measured? What is its purpose? That's what I want you to understand most, what this component is for. It's key to being able to identify problems and understand how things work. I'll talk about that now. Perhaps you have heard about power factor. For example, when in a factory we have many motors, these are the windings of the motors that I want to draw here. What is done is to place a capacitor bank to compensate for power factor. Why? Because coils and capacitors alter electron flow, and this has something to do with low-pass filter circuit or double-pi filter circuit that we had been analyzing in previous modules. It has a lot to do because coils and capacitors function exactly opposite. You will remember that this represented, if we compare it with water, like a cistern, and this could be compared to a centrifugal water pressure pump. Well, what problems can these components cause in electricity? Surely you will remember that sinusoidal wave or electricity provided by electric company is a sinusoidal wave. So if we place many capacitors, what happens is that voltage lags behind. What does that mean? With respect to normal passing voltage, voltage delivered by electric company, due to capacitor charging, I am actually out of time and am over here. Let's see if I can draw it. I'll be around here approximately. I'm out of time. Now if we place motors or coils, I make voltage advance. So thanks to these motors or coils, I'm out of time again, but in other direction advanced. Either voltage advances or load lags behind can also be called. It can be mentioned both ways. Same capacitor lags behind voltage or advances load. It can be said both ways. My way of explaining it is that capacitor lags behind voltage and coils advance it. What happens with this? What happens when we place motors and capacitors? If I only place motors, imagine that we only place motors. Let's erase red representing capacitors. At some point in time, let's assume a moment in time for example here. Imagine what happens when the line voltage is pushing electrons to one side, to one cable, because these are altering the time. At that moment, these will be pushing electrons to the opposite side. So there are certain moments in time, I repeat, there are certain moments in time, that is from here to here, where the coils push to one side and electricity to the other. Here we are fine because we are on the same side. But here again if it hurts us again. You see that it is towards one side and towards another, always from this line I mean, which is voltage 0. There are moments then in time when the voltage is pushing to one side and the coils to the other. What do I do to compensate for this? What is done is to place capacitors. So what I do is delay the voltage a bit that was advanced by the coils, and then what I do is equalize this line and this line, I take it to that side, and we tend to equalize it exactly. There it went too far. So what do? We will want to equalize it. I'll see if I can do it this way. It doesn't let me, it doesn't matter. What we do is move back and equalize again. Now this that we are seeing here, this problem of push and our coils pushing to the other side, is a problem of power factor. What does this mean? In reality, I don't pay for it on my electricity bill. This is a waste or an extra force that I make the company that provides electricity do. What I do then is that my power factor is be down because of all the motors I am placing. What does power factor mean? For example, if they deliver 1000 watts of power, which are what I am consuming, I am taking advantage of little, I am taking advantage of 0.5. The power factor is always between 0 and 1. I am taking advantage of 0.5. That means that I am only taking advantage of 500 watts of power provided by the electric company for 1000 they are sending me. This is not paid on the electricity bill, but it hurts the company that provides electricity. That's why when in a factory there are many coils and no capacitors have been placed, in this case a fine is made to those factories. Well, if I place capacitors I correct this power factor and what I do is raise it. Then maybe I raise it and from 500 watts they deliver me I will be able to take advantage of 0.7, the power factor. Factor is always a number within a multiplication, it says factor. The power factor will be 0.7, so I reach 700 better thanks to capacitors. But placing capacitors, unless it's a computerized capacitor bank, aren't safe because it really depends a lot on how many machines are turned on at that moment. If I place capacitors taking into account all motors turned on when some motors aren't turned on, I'll run the line to the other side. In the end again I'll alter power factor. So placing capacitors isn't safest but always help. If I have many capacitors in one place, my power factor is also altered, but what I have to do to compensate is to place coils. And that's exactly what happens in inverter, exactly the opposite of what happens in a factory. In inverter technology, as I have to filter voltages for high consumption, I have many capacitors that delay the voltage. So what is used to fix the phase shift in power factor? Well, what I place are reactors. The manufacturer places reactors that correct the power factor. That's why the reactor, although many call it coil, transformer, is actually a reactor. It is part of the PFC circuit correction of power factor. The capacitors, are capacitive reactive loads, and coils are inductive reactive loads. If I have inductive loads, I have to place capacitive ones. If I have capacitive ones, I have to place inductive ones to correct power factor, which is this number. I have to raise it. The ideal is that it be 1. If they deliver 1000 watts and the power factor is 1, if I correct it exactly, I am taking advantage of all the watts they deliver me. It's hard to get to 1, but you can. Well, all these components, such as coils and capacitors, used as PFC, are called passive PFC. In all these parts of the course there are many new names, but you have the videos to review as many times as you want. Do it looking at boards, observing, review it well, because this is important to be able to make good diagnoses in inverter. If you don't understand how each component of the circuit works, it will get very complicated for you, this new thing, but little by little you will understand. Why is it called passive PFC? Because it is precisely passive. If I place a coil to compensate for capacitor work, that coil is a fixed correction, not a correction that adjusts all the time. So with this passive PFC, we will try to correct this power factor, and I will be able to reach 0.7 at most. So to improve this even more, what an inverter circuit will do, at least the most sophisticated ones, and for example all in Europe, will have an active PFC. There will be an electronic circuit that takes care of making this correction, helping the reactor, so to speak. Actually, the other way around. The reactor helps a little the active circuit so that it doesn't force so much. Now we will see what we mean by this. We will see a diagram and also see it on the same electronic board in the next video.